Hello guys, welcome to continue the solution of the revision sheet for the fourth quarter exam. Look here, our lesson today is very important. Okay, I'll show you how to use the second derivative test to determine which critical number represent relative maximum or relative minimum. Look here in our problem in question 7. Let the second derivative equal 4x to power 3 minus 2x and let fx have critical numbers at, look here, at this number x equal -1, 0, and 1. Use the second derivative test to determine which critical numbers, if any, give a relative maximum. Here, he would like to know which one at which value of x, which are critical number, we have a relative maximum. Our steps here, I have to replace by each value of the critical number in the second derivative. Okay, the second derivative at f at -1, the second derivative at 0, the second derivative at what? 1. Okay, the sign of the second derivative tell me what is the kind of extrema that we have at each critical number. Okay, and as you know, the critical number occurs at, the relative extrema occurs at critical number. Replace here, it will be 4 plus 2, or what? -4, sorry. Here plus 2, it will be -2. You can substitute by using calculator. Look here, since the second derivative negative, it means that, what about the concavity? It means the function concave downward. Down what? Word. Since it is concave at downward here, as you see, so relative maximum at what? At x equal -1. At 0, if you replace by 0 here equals 0, test fails. Okay? At 1, I replace, it will be 4 minus 2, it will be 2 positives. What is when the second derivative positive, it means it is concave what? Upward. Since if it is concave upward, it means we have relative what? Minimum. At what? X equal 1. But he asks you, what is about, which one of these critical number we have relative maximum at x equal -1. So that is why our choice is x equal -1. I hope you understand. Look here, since it is have concave upward, it means it changes from increasing to decrease. It reaches to the maximum value, it will be relative maximum. And here change from decrease to what? Increase. So it will represent what? A relative minimum value. Okay? For the next problem, look here. In the previous example, I saved the time and I gave you the critical number, or the critical numbers are given. Just substitute in the second derivative. But in this case, I gave you only the function and I ask you to use the second derivative test to determine which critical number. Here I ask about the values of x, not the point. Okay, relative extrema. Extrema here a plural of extremum. It means we have maximum, minimum, two maximum, whatever. Okay, in this case, I didn't give you what the critical number. So I have to find first. I have to find the first derivative. It will be 3x squared minus 2x. Then to find the critical number, set the value of the first derivative equal what? Equal 0. Implies x 3 x minus 2 equal 0. So what are the critical number? X equals 0 or 2/3. Okay? The next step, I have to find the second derivative to replace by these critical number in it. Maybe one of them, maybe any one of them, relative maximum, relative minimum, or neither. Here, replace, finds first the second derivative. From here, the second derivative will be 6x minus 2. Replace by this value in the second derivative at 0, the second derivative at 2/3. Here it will be negative 2 concave downward, so we have relative what? Maximum at what? At x equal 0. At x equal 0 we have relative maximum. Okay, 2/3 it will be 2. Just replace by use calculator. This means since it's the second derivative positive, the curve was of a concave upward. In this case, we have a relative what? Minimum. We have a relative minimum, okay? That is why our choices here, the relative minimum at what? At x equal 2/3. That is why our choice is a relative maximum at 0 and relative minimum at 2/3. Here I give you the answer key. But in the session, I show you how we get this result. Okay? I hope you understand everything. Here, look here, find all inflection point of the graph of the function f(x) equal x power 4 minus 6x power 3. Miss, before I begin to solve any problem, I have to know what I'm asking about it. I'm asking about what? Point of inflection. What is the properties of the point of inflection? The second derivative equals 0 or does not exist. The graph of the function has a tangent line. The third one, the function change is a concavity from concave upward to downward or from downward to upward. Okay? So in this case, I have to find the zeros of the second derivative, okay, and check the concavity. So I have to find the first derivative, which is 4x to power 3 minus 18x to power 2. Then find the second derivative, which is 12. I find the second derivative by differentiate or find the derivative of the first derivative. 2 minus 36x. Set what the second derivative equal what? 0, since our polynomial, our function is polynomial function. Implies 12x to power 2 minus 36x equal what? 0. Take 12 and x as a common factor, it will be x minus 3 equal 0. So x equal 0 or x equal what? 3. Maybe any one of them or both of them are inflection point. This number, maybe they will be inflection point. How to identify this one? By checking the concavity. How to check the concavity? By using what? The second derivative. Do you remember this one here? 0. How to discuss the concavity or identify the interval. But here, I'm not identifying the interval. I'd like to check what? The concavity. Then, test value here, negative 1. Here 1. Here we will take what? 4. Replace in what? In the second derivative. If you replace by negative 1 in the second derivative, it will be positive. This means concave what? Upward. If you replace by 1, it will be negative. It means concave downward. Okay, just replace. By 4, it will be positive, it means concave upward. Since at each value of x equals 0 or x equals 3, the second derivative equal 0, and the behavior of the function change its concavity from upward to downward and from downward to upward. In this case, inflection, okay, inflection what? Point at 0 and f at 0. Since you talk about point, I have to find the x coordinate and the y coordinate. And what else? 3 and f at 3, which are 0 and f0 replaced in the original function. In what? Original function. 0 and 3 and the negative 81. That's all. Since we ask about inflection point, I have to find the values at which the second derivative 0 or does not exist. That is the first step. The second one, I have to discuss the concavity of the function around this point. If the function change its concavity at each one of them, so each one of them will be inflection. Or change the concavity at only one of them, it will be. So we need to condition 0, the second derivative 0 or does not exist, and the function it change its concavity. Since we talk about point, we have to find the x coordinate and the y coordinate. Okay, clear? Here, this one, it's so easy as we solved it before. If you would like to find the relative extrema using the second derivative test, it's so easy. Just find the critical number and substitute in the second derivative. It is positive, so it will have relative minimum. Negative, we have relative maximum. Just all. So here it's so trivial. The first step, find the first derivative. It will be 4x to power 3, okay, plus 12x to power 2. Then we have to find the critical number. Since you talk about extrema, I have to find the critical number first. 4x to power 3, because the extrema occurs at what? The critical number. X to power 2 equal 0. Take 4x to power 2 as a common factor. X plus 3 equal 0. So x equal 0 or x equal what? Negative 3. As you see here, we have two critical numbers. To identify at which one of them we have a relative extrema by using the second derivative, so I have to use the second derivative, which is what? 12x to power 2 plus 24x. Okay, then find the second derivative at the first critical number, the second derivative at the second derivative critical number. Okay, at 0 it will be 0 fail, test to A, test fail, test fails. Then replaced by negative 3, it will be what? Wait, 108 minus, no, it will be positive. Find the value, it will be what? Positive. If it is positive, this means it is concave upward, so we have a relative minimum. We have relative minimum at which point? Negative 3 and the f at negative 3. Why you replace in f by x equal negative 3 to find the y coordinate, which will be relative minimum at what? Negative 3 and negative 27. I hope you understand well. So to identify the relative extrema using the second derivative test, I have to find the critical number and replace by them in the second derivative. If it is positive, so we have a relative minimum. If it is negative, we have a relative maximum. If it is 0, the test fail and we can use the second derivative test to identify the extrema. And in this case, we have to use the first derivative test. Here, let f be a polynomial. Please focus with me. Be a polynomial, okay, such that f negative 2 equal 5. It means the coordinate here negative 2 and 5. Okay, this point, okay. The first derivative at negative 2 equals 0. It means, what is the meaning the first derivative equals 0? It means negative 2 is the critical number. That's right or not? Because from the definition of the critical numbers, the values of x at which the first derivative equals 0 or does not exist. Okay? Look here. This means we have a critical number, negative 2. If second derivative at the equal 3, what is the meaning of each given? I just interpret each given. The first given, it means we have this point on the fx. Negative 2 and f point is what? Point on the satisfy the function, okay? From the second given, the first derivative equals 0, it means negative 2, the value of x at which the first derivative equals 0, critical number. If the second derivative at this critical number positive, it means the function concave upward. Concave what? Upward. In this case, we consider negative 2 and 5 at x equal negative 2, we have what? Relative minimum. Okay? So here, since all of the choices talk about the extrema in this case, negative 2 and 5, the ordered pair or the point or the coordinate of this point, negative 2 and 5, represent what? Relative minimum of the function. That is why our choice is what? Our choice is B. Just interpret each given. F of negative 2 equal 5, it means we have a point negative 2 and 5 satisfies the function or on the graph of this function. What is the meaning of the first derivative at this point equal 0? It means we have a critical number. We have what? Critical what? Number. Okay, grade 12, that is the last question in part 3 of the revision. Okay, we will continue the solution of the sheet. Starting from question 2 in part 4. Wait for the part 4 of the revision. Thank you for joining the session. Bye-bye and have a nice day.